So the next example, I have subtract these two, find the difference between 2n over n squared minus 9, and then minus, and then 6 over 9 minus n squared. Again, it's the same kind of problem, right? All these problems today in today's video are the same kind of problem where the denominators are opposites. See how this denominator has a 1n squared, this one has a negative 1n squared, the opposite, times negative 1. This has a negative 9 term, this has a positive 9 term. Again, just differ by a factor of negative 1. So every term in this denominator is negative 1 times this denominator, so these are indeed opposites. Alright, so again, I just simply multiply one of these fractions by negative 1 over negative 1. So I'll do it to this one. And again, the denominator here has multiple terms, so I'm going to put that in parentheses where I have to distribute the negative 1. Alright, so this is equal to then the first fraction I didn't touch again, so it's 2n divided by n squared minus 9. Then we have minus, and then the numerator now here is 6 times negative 1 is negative 6 divided by, and then the denominator, again, I'm going to distribute the negative 1. Remember, negative 1 times 9 is negative 9. Negative 1 times negative n squared would be positive n squared. And again, I like to put, and I would recommend you also put your polynomials in descending order, highest power of n first. So I'm going to put the positive n squared first, and then the term of negative 9. And you will indeed now see the denominators have are the same for these two fractions. Alright, so now that they're the same, I can combine them. I can subtract them. So remember, in addition and subtraction, when the denominators are the same, that common denominator is the denominator of the resulting difference, or sum. And then we're subtracting the numerators, right? So now these are both one-term numerators, so I don't really need to put parentheses around them like I did in the last example. So it's just, the numerator 2n, and then minus negative 6, right? But minus a negative, subtracting a negative is just adding a positive. Remember, subtraction is just addition of the opposite. So subtracting negative 6 is simply plus 6. Okay, and this is great. This is now a single fraction, and I'm almost home. Indeed, this fraction minus this fraction will be equal to this fraction. But I would like to, again, further simplify. So once you have a single fraction, I'm going to start, factoring, factor the numerator and denominator completely, and see if there are any common factors, and cancel. So I have the numerator; those have a common factor of 2. I pull that out. It'll be 2 times n plus 3. Divided by, and then the denominator is the difference of two squares, right? N squared minus 3 squared. So that would factor to the quantity n plus 3 times the factor n minus 3. All right. And then, as with previous examples, as you saw, before I do any canceling, I'm going to put down here some values that n cannot be replaced with. Alright, so this fraction minus this fraction will be equal to this fraction here as long as you never have a denominator of 0. And I'm seeing in this final form here that if n were negative 3, this n plus 3 factor would be 0, and then this would be 0 times whatever, and the whole thing, denominator would be 0. Also, n cannot be positive 3, right, because there's this factor of n minus 3. And if n were positive 3, 3 minus 3, this factor would be 0, and then you'd have 0 times 6, and the denominator would be 0, and that's bad. That's undefined. And that's it. Those are the this n squared minus 9, 9 minus n squared. These two factors are the only ones showing up in any denominators throughout this problem. So the only two bad values, the ones I can't plug in for n, are -3 and +3. Alright, so now that I've noted that to myself, I'm going to cancel some common factors here. I notice that the numerator and denominator have a common factor of n plus 3. Alright, so those become 1 again technically. And what we're left with finally is that this fraction minus this fraction is equal to 2 in the numerator divided by, and then the only factor left in the denominator is n minus 3. If you want to put it in parentheses, fine, but since it's the only factor left, no need for the parentheses, right? So just n minus 3 in the denominator. And again, the only way this fraction minus this fraction will be equal to this fraction here is if I replace the value of n with something other than -3 and +3. Okay, and again, you can test this. This time I'm not going to write it out, but if you want to check it out, try plugging in values for n. As long as they're not 3 or -3, the value of this fraction minus the value of this fraction will be equal to the value of this fraction, since we did everything correctly. So try n equals 4, 0, 100, 5, a fifth, -7. As long as it's not one of these two, the difference of these two fractions should be equal to this one. Alright, and then I have one last example. Again, here a difference. Find the difference between these two fractions. Sorry about the pause there. So I have 2k over 6k minus 6 minus the 9 plus 4k over 6 minus 6k. Notice again the denominators are opposites, right? This is a positive 6k, this has a negative 6k, this has a negative 6, this is a positive 6. Every term in this one is just -1 times the terms of this one. They're all opposites. So again, very simple fix. Multiply the numerator and denominator by -1. And when I do that, again, now that both the numerator and denominator of this fraction have multiple terms, okay, so I'm going to put parentheses around those, and we're going to distribute the -1. So this will be equal to, the first fraction stays the same, 2k divided by 6k minus 6. Then we have minus, and then again, I like to put things with the highest powers of the variables first, and then descending order. So this one would be -9 and then -4k. So -4k first I'll put, and then the -9. There's the numerator now of that second fraction. And then multiplying this by -1, I'll put the -1 times -6k. I'll put +6k first, and then -1 times 6, -6 second. Okay, so now we're seeing indeed they have the same denominator. We can put them together now, and that common denominator will stay the same, 6k minus 6. And we're combining the numerators. Now this one, 2k is just a single term, just 2k. You don't need a parentheses around that. But we're subtracting from this 2k this entire numerator, and it has multiple terms, so I'm going to put it in parentheses, minus the entirety of -4k minus 9. And you can see why the parentheses are necessary here, because I'm going to have to distribute this -1. Right? Again, a minus sign anywhere, anytime you see a minus sign, it's like having a factor of -1, right? -4 is -1 times 4, -9 is -1 times 9. So this is -1 out here, and I'm distributing it. Alright, so then we've got 2k, I'll write it out here, 2k, and then minus -4k would be plus 4k, and then minus -9 would be plus 9. All that over, and then 6k minus 6, And when we combine some like terms up here, totally simplify the numerator, it would be 6k plus 9. Right, the 2k and the 4k go together, and the 9's not going to go with anything else because it doesn't have a k attached. Divided by 6k minus 6. Oops, pardon me, that should be a 6. That's 6 minus 6. Sorry about that. And this is great. This is the difference. If you took these two fractions I had originally, this fraction minus this one, it will be equal to this. That's just, again, we like to simplify. So here's where I'm going to do some factoring. The greatest common factor of 6k plus 9 is 3. Right, 3 goes into both terms, so I pull a 3 out. And when I do that, the remaining factor will be 2k plus 3. In the denominator, same thing. Now the greatest common factor of 6k and negative 6 would be 6. So I pull 6 out, but I do want to factor completely, right? So we'll break down 6 even further as well. So when I pull 6 out, 6 breaks down even to 2 times 3. So here's your 6. This is 2 times 3. This is the 6 I'm factoring out. Times, and then when I remove 6, what's left over would be k minus 1. Alright, and again, before I do any canceling at all, I am going to point out values that k cannot be equal to. Alright, so if you look through this, the only real number that makes a denominator 0 would be the value of 1. Right, if I replace k with 1, you get 1 minus 1 here as a factor in the denominator, so you'd have 6 times 0, which would be 0. And that's no good, right? And that's the only number that makes any denominator equal to 0. So k cannot be 1, but anything else is fine, right? As long as you don't make a denominator 0 ever. All right, so now looking at this, I see there's a common factor of 3, and that's it. Just the 3's cancel. So what I'm left with, finally, is the numerator is this 2k plus 3. And since that is the only factor, I don't need to put it in parentheses, right? 2k plus 3 divided by, and then the denominator has 2 factors left, so I'm going to keep the parentheses around the k minus 1. A factor of 2 times, and then a factor of k minus 1. Again, as long as, so this fraction minus this fraction is equal to this fraction, as long as the value of k is never 1, right? Is not replaced with 1. Right, and this is perfectly well and good here. Right, there are no common factors anymore. Totally simplified. Now, if you'd like, some people don't like parentheses and junk, so like you can multiply this by 2 down here and have 2k plus 3 divided by, and then distributing the 2, you'd have 2k minus 2, and then say that this fraction minus this fraction will be equal to this fraction, which is the same as the one I have here. As long as k is not 1 again, right? So this is fine as well, what I put in the little cloud. And again, check. Try some values out, right? Some values other than 1. Plug in, 2, 3, 1.5, negative 5, 0 for k here and here and here, right? And the value of this fraction minus the value of this fraction should be equal to the value of this one. And again, test it out, and you'll see that will indeed work. All right. So at the end of these, I like to always say, please try to get material on your own first. Read through the text, read through the material, author's examples, try to understand them as best you can, and work through practice problems. Look at answers in backs of books if they're provided. And don't just give up after the first attempt. Keep at it. If after several attempts it's still not clicking on a certain problem, maybe go back and read through the text again. Perhaps something will click the second or third time you read through it that didn't click the first time. And if after that, still not getting to you, it is not a sign of weakness whatsoever to go asking for help, go looking for help. Ask a tutor, ask a teacher, ask a friend, or someone else in the class who knows the material. and you know, look for videos like this one, or ones out there, plenty of them out there that are better than this one. And you know, just keep at it, stay persistent, keep working hard, and I know you can get it. I know you can, and try your best to have fun with it as well. Thanks.